Hello, everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch, developer advocate here at AWS. And if you are building or planning to build a SaaS product, this is the show for you. Because on this show, I bring on SaaS experts to talk about specific topics around SaaS and let you, our viewers, ask any questions you might have. And hopefully by the end of the hour, you've learned something new on the SaaS topic. We want to make it interactive, so keep your comments, your question coming throughout the hour. And this week, I'm happy to be joined by Mehran Najafi and Michael Peltz, colleagues from AWS. Welcome to the show, fellas.
Hi, everyone. My name is Mehran Najafi. I'm a senior AWS solution architect. I'm also part of AIML TFC group and interested on AIML at a scale, and very happy to be here today to talk about how you can build machine learning as a service on AWS, and we'll show you a quick demo on what the steps involved there.
Hi, everyone. This is Michael Peltz. I'm Senior Solutions Architect in AWS. I help companies in the EMEA region to build well-architected SaaS on AWS. SaaS and machine learning are my favorite topics. Thanks, Gunnar, for this opportunity to talk about them today.
Great to have you here, both of you. And the topic of this week's show is SaaS tenant isolation using Amazon SageMaker. You both touched on the topic there. So can you just give us a brief overview of what that means to begin with?
Sure, Gunnar. So you know that over the last decade or two, companies, they have spent millions of dollars and to build machine learning models more for internal applications. Now we see that the customers, they are trying to expose those models, provide those models to other customers, basically as a new way of getting more revenue. Now that now they need to know, okay, how they can build those kind of applications. Many of those customers, they are looking at microservices architecture, where you expose each of those tasks and functionalities as a service. And this fits very well with machine learning, as a service. And then when you combine these two together, we come up with this idea and this model of machine learning as a service applications.
And how does SaaS come into play here?
Yeah, that's a great question. And let me share my screen. So when, as the machine learning as a service provider, you need to build, and you are looking to build your application, there are a number of decision factors and decision problems that you need to tackle. Usually you need to deal with multi-tenancy. You have multiple clients on your environment, so you want to isolate them from each other. You need to deal with a noisy neighbor problem. They are usually very compute and storage intensive. You need to probably offer them as a multi-tier subscription models. You need to track them, their cost per tenant. So as you see, and probably everyone here in the show, they are familiar with basics of SaaS. So those patterns and those problems are very well studied in SaaS. So very good news here is that we can borrow as an ML as a service provider from SaaS and only focus on those services which are very specific to machine learning. As you can see, I put them here in those green boxes. Basically, two big components. One is to building a model as a pipeline. That's something that I'm going to focus more during our talk today. And then the other component is on deployment and inference. That's something that my colleague Michael is going to talk about them today.
And you, the viewers, if you're watching this, don't worry. It's not going to be slide heavy this session. There's going to be a lot of demos throughout this hour. So no worries there. And then what are the key differentiator services for this?
Yeah, so, first you need to build a model, right? So every ML as a service application, they usually have a built-in model. So first you need to have a pipeline automated Sometimes that's a shared model for all your or some of your tenants, and some of them you have a customer specific model. When you have your model ready, then you need to put them in production, put them in for prediction, for inference, sometimes for batch processing. And now we also need to make decision. Am I going to have the same deployment for all the tenant, or I will have a tenant a specific deployment? So these are usually the two big components of machine learning as a service application that as a developer, you need to pay more attention to them.
And what does the inference service do in this model?
So the inference is basically, making the prediction, or, doing doing analysis on the data. This is usually when you put those model in action. First one, building a model is more offline, and it could be doing in the background. But when you have that model ready, you put it into the action. You put it for online transactions, and that's something that your customers are going to use when your model is live, basically.
So should we start by looking at machine learning training in a multi-tenant environment then?
Yeah, definitely. So first, let me show you this slide. There are two ways, or two main patterns that we have seen with our customers. One of them is they use the same shared model for all the tenants. And we can look at some examples, such as the same model for predicting if a customer defaults on their mortgage. Different banks or different institutes can use the same model in the same country. And the other one is that we have a tenant-specific machine learning model. So one tenant, one customized model per one tenant. For example, if you want to expose face recognition to identify employees from non-employees. So every company can ask the machine learning as a service provider to customize a model based on the faces of their own employee. And then we as a provider put it into a box dedicated to that customer. And then during inference, it can detect this person entering the building. Is it my employee or not? So you see here, we have probably one model per tenant, which is very different from the shared model.
And then I think when we talked about this before the show, you mentioned that you and Michael are about to publish a blog post on this topic for using SageMaker to build a machine learning pipeline. Can you just tell me briefly what you talk about there?
Yeah, exactly. So there is a blog post from AWS that both Michael and myself we wrote, and that hopefully should be published in a week or two. So this has lots of detail about how you can build such a model build pipeline. I have the architecture here. This should give you some high-level idea about what are the different components there. But I encourage you to go and check this in a week or two, and then you will see much more detail about this. A very high level, and this is something that I'm going to demo you shortly. This is good that give you some idea that how these building blocks can come together to easily. That's the point. If you want to build this system on AWS with minimum effort, you can get it to work, and then that thanks to many of these services which can be used here. Very high level. As you can see, we have different tenants. We have tenant A and tenant B. So each one, they need to have their own model trained for their own specific use case. Tenant A put its own training data into the tenant A S3 bucket. S3 for storing. This is like a object storage by AWS. So they put their data into that S3 dedicated to tenant A. Then that triggers event using the Amazon event bridge that will get triggered when there is an upload in that S3 bucket. Then this is the point here. There is a rule per tenant, which is used here to parameterize pipeline execution. So Amazon SageMaker, this is a managed AI ML solution by AWS. It has a concept of pipeline. So a pipeline can have a number of different steps for doing machine learning and AI tasks. For example, for data processing or model training, evaluation, analysis, and also deployment. So based on your use case, you can define a pipeline. And then when there is an event bridge, it can create one instance of the same pipeline for your own tenant. So there is a parameters here that you can customize. You can pass those tenant specific values. Then that initiate a pipeline execution. The pipeline go through all the steps. And finally, when it has a trained model, it put them into another tenant bucket for model artifact for that specific tenant. I think it's a good time, Gunnar, that I will switch to my IDE and show how it would work in action.
I think so as well. And just a reminder to the viewers out there, hi to everyone in the chat. This is Building SaaS on AWS, and I'm joined by Miran and Michael today to look at machine learning for SaaS applications. So post any questions you might have in the chat.
Okay, so just remember those major components in the architecture I showed you. Very first one was S3, that is that online storage by AWS. As I mentioned, there is a tenant-specific bucket. Here I have two buckets, one for tenant A, one for tenant B.
Can you zoom in a step or two?
Sure. Is it good or you need more?
Yeah, I think that's good.
Okay. So inside that tenant A bucket, I have a training data folder that I use to store the training data. So at the end of my demo, I show you that how you can upload a new file here. But the idea here is there is a tenant, that there is a S3 bucket per tenant. Very easily you can create one, and that also this can be automated. The next component here is that event bridge. So very similarly, there is one rule per tenant. There is a tenant A rule and tenant B rule. Let's look at what is inside that tenant A rule. Sorry. So first, we want to know that how this is triggered. You see that when there is an object created notification coming from S3 from this bucket, right, from Twitch -tenant-A, that's the bucket I showed you. When a new training data is uploaded there, this event gets triggered. When it is triggered, what does it do? It's basically go and execute a pipeline. If I want to show you what is inside that pipeline, so there are parameters, and these parameters are the key to this concept that used to customize that pipeline for this specific tenant. What do we pass? Remember when I was talking about the decision problems that ML as a service provider need to address? One of them was, about noisy neighbor problem, that we don't want that one tenant consume all the computation and storage power of the system, so the other tenant cannot use them. So here, thanks to the Amazon pipeline, SageMaker pipeline, it creates dedicated resources per tenant. How we can customize that? We can pass some parameters. For example, here for processing instance, I can set the value to like ML type of CPUs, the number of those CPUs I want for processing. This is the pre-processing before the training is started. Then I can also define the training instances. I'm using, for example, here 4x large, which is a very powerful EC2 instance. Then this is an important one, the input data URL. This is that S3 bucket. So as you can see, I have a Twitch dash tenant dash A. So this is the bucket I showed you, and that belongs to the tenant A. I also can identify, okay, which bucket I want to use for storing the model artifact. And also, this is another important one. That's the role ARN. So this role ARN, this is IAM role. I will show you quickly, but it enforces that permission that when this SageMaker pipeline is executing, it only can access to the tenant A data. That's something that we want to make sure that, you know, when a pipeline for tenant B is executing, it doesn't, and it cannot have access to the tenant A. That's a very important concept in SaaS, that, you know, we need to enforce that tenant isolation. Let me quickly, go ahead.
Just a question there then, given that you have, you have tenant-specific resources in this case, are there any limits to think about? How many tenants you can onboard into this type of solution?
That's very, very good question. So there are limits, but there are a workaround for each of them. For example, you know, for S3, there is a soft limit of 100 and a hard limit of 1,000. That means that by default, you have a 100, but you can send a request to increase it to 1,000. But if you want to go over that limit easily, you can use prefixes in S3. Similarly, you know, for role, so there are limits like 5,000. But Michael is going to show you that how you can use ABAC for building dynamic roles. And, you know, if you have a chance to look at that blog post coming soon, it tackles about some of those limits. But this is the very basic and simple model. But it could work probably easily up to like 1,000 customer. But as you get more customer, you can enhance it by adding more flexibility to deal with those limits.
So, question from the chat then. Cloud Touch asks, can you share in the GitHub repo for this demo?
So there is there is no GitHub at the moment. That's something that we are working on it. But hopefully soon we will publish another blog post on walkthrough, you know, show you that how you can, what are the steps that you need to do to implement something like this. But this is very, as I will continue and you see this is very easy to configure. So Amazon SageMaker has a default project that we are using them here. Even if you see this recording later and you read that blog post easily, you should be able to implement this. But that's something that we also work to have a GitHub repo on this as well. Okay, let me go to another component. This is for IAM roles. So very similar concept. We have one role per tenant, one for tenant A and one for tenant B. So there is a policy here that it enforces that anyone assume this role can only access to this bucket, right? That's the key here, that Twitch-tenant-A. So when the pipeline for tenant A is executing, it cannot have access to tenant B data. And as I mentioned, if you want to scale up this, then, you know, we can pay more attention to when Michael is talking about ABAC, the same concept can be applied here. So now we have seen our S3 bucket, we have seen our event bridge rule, and we have seen our basically IAM role. So now it's time to look at our SageMaker. This is the SageMaker pipeline. That's probably the key component of this architecture. That's why it is simple to leverage this basically SageMaker pipeline. This is very customizable, but if you just create a sample project in SageMaker pipeline, this is one that processes Avalon data, create a model for you. This is the model. This is the pipeline that comes. So it has different steps. The first step is to pre-process data, basically downloading the data from the S3 bucket, bring it for analysis, do some analysis, move them to a data frame, then do the training step. When your model is ready, do some evaluation to make sure that the accuracy is good. Then if it passes all those benchmark and those those metrics, then we register them into a bucket belong to that tenant. Now let me just move to the code, which is more interesting. Show you what is there. This is the pipeline code, pipeline.python code. Very first thing you see here that we define a pipeline. We put some parameters, and these are the parameters that we pass from that event bridge role, right? So
we might need a zoom step or two here as well.
Sure. Yeah. Is it good now?
That's great.
Okay. So very first thing is defining that pipeline, the pipeline parameters, the same parameters that we put into that event bridge rule. So, the point here is that this pipeline, when it is created, it is customized per that tenant. So, for SaaS, we know we only want to keep one source of truth, one code base. We don't want to have one code for tenant A. We don't want to have one code for tenant B. That's a very key point of SaaS, to make maintenance of our applications simple. And here we use these parameters to customize it per tenant, per tenant A here, or later for tenant B. First, we define the parameters, and then we define steps. There are a number of steps here, as I showed you in that graph. So first, let's go to the step process. This is the first step here that we define. So just as I said, it basically download the file from the S3 bucket and then process it. What we pass to this is that input data. This is the bucket for tenant A and the role ARN. That role that only allow this SageMaker pipeline to access to the S3 bucket for tenant A. Now we go to that file, and it also need to execute this file, pre-processing file, the script. This is the file that download the file from this is the script that download the file from S3. This is the important function, assume role, that it takes that role ARN that belong to this tenant A, and then when it assumes this, the S3 access for this pipeline is restricted to tenant A data. This is we are downloading it. As you see here, we use S3 like 423 SDK API to go and download a file from that specific bucket. And the bucket value comes from that parameter again. That is, that is only for tenant A. So here you can see that, by very simple addition of the code of leveraging parameters, we enforce tenant isolations at the bucket level and also at the permission, so that only access to the tenant specific bucket. When that model is trained at very last year, we put them into a data frame to make it available for the training step. Next step is for training. This is the training step. And another use of those parameters is that, as you can see here, we can define that for this tenant, probably it belongs to the basic subscription tier, which they pay less. So we only probably assign just one number of CPUs and small, and just not the most powerful CPU, because this tenant can wait for the training to be completed. If we have a more higher tier customer, so we can go with more CPUs and more like a stronger instances. So when
is there anything else you could do in terms of tiering to have the premium tenants perhaps go ahead of the queue, the training queue?
Yeah. That's fully customizable. So you can define as many tier as you want, and then you can pass different parameters for each of those. What we have seen with customer, they usually have a basic tier, which is probably the majority of customers would be under that category, and then they define 2 or 3 more tiers. But the point here, this is fully customizable. You can pass as many parameters as you want, as many variations of those parameters as you want. So another important parameter here is this tags. So you can define and you can attach some tags to your processors. And then it helps you later that when you go to the cost explorer, you can see that how much these training cost for your tenant. So this help with the tenant cost per tenant calculation. When that training is completed, it put them into a bucket, which is output path here. And when we pad the same S3 bucket for that tenant, so that the model artifact will be copied there. So let me quickly show you, how this could be initiated. If I go to my S3 bucket, so there are two. So I'm going to here to the training data. I'm going to upload a new version of this file. That Abilene data set. So this is done. Then I'm going to go to the tenant B as well and do the same process, uploading this file there, assuming these two are different file belonging to the different tenants. Now, if I go back to this pipeline, you can see two instances of that pipeline are executing now. So each pipeline has access to that specific S3 bucket. And unfortunately, it takes about 10-15 minutes, so we cannot wait for this to be completed here. I just want to show you the idea. And when that training is completed, what happens here is that model will be created here. Like, for example, for tenant B, here you see I have executed this before. So there is one model created per execution, and this is basically the model. So now the model is ready. So you can take it, put it into the inference, and that's something that Michael is gonna talk about. What are the different options to put them in the production, and also we're gonna show you a demo. Any questions before we move? Yeah.
Well, one question is around scale of this. So we talked about you said I think you said up to about 1,000 tenants in this type of solution. Are there any considerations in terms of what if those 1,000 upload a file to their bucket at the same time? Do you need to consider that?
That's a great question. And yeah, in that blog post, there is a scaled version of that architecture that we use the queues, that SQS, that's simple queuing services from AWS and Lambda, to basically only allow that pipeline execution when there is enough capacity in the pipeline, assuming that thousands of tenants, they upload their training data at the same time, and we only have capacity for running 10 pipeline. So that queue will basically queue them, put them into an order, then that we can have a number of different queues per that subscription tier, and only allow a new pipeline to be executed when a previous pipeline is completed or when there is available pipeline, if a pipeline available for the training.
That's great. And I think we say that on every episode here, we should always plan and build for scale, because that's where we're aiming with most SaaS solutions.
Exactly.
All right. So thanks for that demo, and reminder to the viewers that this is Building SaaS on AWS. If you just joined us, we've had a look at how to build pipelines for machine learning in a SaaS solution with separated tenants. And if you have any questions, if you have any comments, just post them in the chat. And now with that, I think it's time to switch over to Michael.
Yeah, thank you. So this part is about the real-time inference architecture in a multi-tenant environment. And it's based on another blog post co-written with Joshua Fox from Do It International. I'll start with 4 slides, and then I'll switch over to a live demo. So how do you expose models to real-time inference? You do that with SageMaker endpoints. SageMaker endpoints is a fully managed service designed just for that. But you typically don't want to expose it directly to the end users. You do that via some sort of a higher level API that provides additional functionality like authorization or throttling. Here on the slide, you see a sample serverless inference architecture just for one single tenant. So in this implementation, we have an API gateway triggered by end user request to do an inference. It triggers a Lambda, and the Lambda calls the inference API exposed by SageMaker endpoint. So this is just for one tenant. What happens when you have multiple tenants? So you can either have a dedicated stack like this per tenant. In the common SaaS methodology, this approach is called silo. Or alternatively, you can create a single stack, dedicated a single stack and use it for multiple tenants. So reuse the same stack for multiple tenants. This approach is called pool.
Is there any recommendation on when to use silo, when to use pool, or use the one over the other?
Yeah, absolutely. So that's the kind of question you ask yourself for each and every component in multi-tenant architecture. So silo is usually a good fit for top tenant tiers with a strict SLA that requires consistent inference time. It might be good fit for highly regulated industries that require maximum isolation, like banking, for example. On the other hand, pool is a good fit for cases when you optimize for cost. You can support more tenants with fewer components. So it also reduces the risk of hitting account limits mentioned before, right? So it might be, I would recommend to consider this for lower tenants, for lower tenant tiers, which are more tolerant to noisy neighbors. Today we'll talk in detail about the pooled approach. We will also see a demo of that. So in the pool, we share resources. Here on this diagram, we have got the shared API gateway, Lambda, and SageMaker endpoint. In this architecture, we use a single endpoint capable of serving large number of models. It's called multi-model endpoint. It uses a shared container that hosts multiple ML models. For each inference call, we specify which ML model to use, and then models are lazily loaded from S3. In this architecture, we use one shared Lambda, and therefore one execution role for all tenants. So even though the Lambda is shared and getting requests from multiple tenants, we still have to prevent one tenant from accessing ML model that belongs to another tenant. That requires a security context to be created per each individual request. And we will use ABAC, attribute-based access control, and IAM to implement this. Just to quickly define what ABAC means. As the name suggests, ABAC is the authorization strategy that defines permissions based on attributes. It's not an AWS specific concept. You can assign attributes to principals and resources and allow access only when these attributes match. On AWS, these attributes are called tags, and IAM policies support tags. You can write parameterized policies and use tags in conditions.
So how does it choose which model to use? Is that based on the tenant who initiates the request? How is that? How does that work?
Yeah. That's right. So that's an interesting question. You can definitely tackle that at the application layer. So you can just put a code in your Lambda that decides which model to be used, right? And that's a fair approach. And all is good as long as everything works as expected. But you typically don't want to assume well-behaved code. Tenant isolation is a security requirement. As always with security, you would typically want to have multiple level of defense. And application level security is your first line of defense. You can extend that with infrastructure level of defense, which basically define the guardrails or flexibility boundaries for your application level policies. So let's zoom in on what's happening in the Lambda. That's basically the same slide as before. We are zooming in on the Lambda. So Lambda execution role has a parameterized IAM policy attached with tenant ID variables. We take a closer look at it in the demo, by the way. So very soon we will see live demo of this. These variables are replaced by IAM with actual tenant ID when invoke endpoint is called. So tenant 1 in this particular case. Tenant ID is delivered to Lambda with each request. Typically, it's done by including tenant ID into JWT, the custom claim. So that assumes that user has been authenticated before calling predict or inference function. The Lambda extracts the tenant ID out of JWT or JOT and passes it as a parameter to the assume role function. By doing so, you attach tenant 1 tag to a temporary session. Assume role returns temporary security credentials that are used then to invoke the endpoint on tenant 1 model. If you try to use tenant 2, it will just denied by IAM. All right, so let me switch to the demo. I'll use Jupyter Notebook for this demo just because it makes it very easy to do a code walkthrough. If you are not familiar with Jupyter, it's an interactive open source computing platform. You can use it to prepare and process data, write code to train models, deploy ML models to SageMaker, and so on. So for this demo, I trained 2 regression models using the XGBoost algorithm. But it can be any other ML model and algorithm. The resulting model artifact I put in the same S3 folder. I also provisioned a multi-model endpoint and configured it to load the models from the shared location on S3. So let me demonstrate this to you. So I'm opening the SageMaker, and I've got here 3 endpoints. This is the multi-model one. Let me show you that it's a multi-model.
Let's zoom a few steps, Michael.
Oh, sure. Yeah.
Yes.
All right. So it's a multiple models mod. And if I click here, you will see the 2 model artifacts that I prepared in advance and put them both in this shared bucket. So the first one starts with tenant 1 and the second tenant 2. So I'll demonstrate how to isolate access to these two models using ABAC and IAM. The idea is this. When a request is coming from tenant 1, you create a temporary IAM session that is allowed to only access tenant 1 model. If you try to execute a cross-tenant ref inference, it will be denied by IAM. So how do I technically create a temporary session? So it happens in this create temp session function. As you can see, it receives two parameters, the access role and the tenant ID. And this function returns both of three sessions that encapsulate temporary security credentials, access key, security key, and session token. Let's take a look at this function. As you see, it's imported from the utils package. So let's open it up. All right, so this function resembles the function that Mehran demonstrated in the first part. It again uses the STS assume role, but there is a little important twist in here. So as you see, this function also passes tenant ID parameter, key tenant ID, and the value, which is the parameter we passed into the function. In here, role ARN is the role which is going to be assumed. Note also that we use tenant ID to give the temporary session name. And then the printout here is the temporary session name. We'll look at it in a second. And then return the Boto3 session object. Let's go back to the notebook. All right. So let's execute this. Now, that's the ARN for the temporary role. And as you see, it includes tenant 1 at the end. And that's quite a handy feature because any action that you do under credentials of this particular temporary session will be logged in CloudTrail using this ARN. So you can easily track activity of tenants that make use of these temporary sessions. So if you want to create temporary session for tenant 2, all I have to do here is to change tenant 1 to tenant 2. In a real application, you would extract tenant ID from a JWT and passes into the function as a parameter.
So you're basically creating two different IAM sessions with different permissions than using the same IAM role.
Yes, exactly. This is where the ABAC comes into play. The magic happens in the IAM policy attached to the assumed role. So let me show that. This is the assumed role. And that's the assigned to it policy. Note this condition with tenant ID parameter. At inference time, the policy is evaluated and the tenant ID is replaced with the actual value from the session context. So this condition restricts invoke endpoint action to models starting with a specific tenant ID. Inference for any target model with a different name will be denied. So let's review the inference code and then run it. Note that SageMaker client in here is created using the temporary session, right? So basically anything you do, any action you take by using this client will be executed under the temporary session credentials. That means that permissions to execute any API call are checked against the policy that we just reviewed. So let's talk about the parameters in here. So we pass to invoke endpoint. So that's the function that actually calls the inference endpoint, right? So we have to pass here the endpoint name, which is defined here, the multimodal endpoint that we saw before. I just pass in one record to do an inference with. And I also specify the target model name to be used for the inference, and it's defined in here. So you would probably ask if it's so easy to change the context. You just have to change two parameters, the tenant ID in here and model name in here, and you can easily, as a result of the bug or as a result of, hacker activity, it can be done not intentionally. So how do you deal with that in a real application? So I used two cells on purpose here. Just take a look. In a real application, you would typically separate session creation and inference into two different components. In the serverless application, you would probably put session creation code in API Gateway Lambda authorizer. That would be a good choice. And then you would pass session security credentials to other component, Lambda, for example, where you can use them for inference. All right, so this policy that we just reviewed and the role, this one is quite powerful one. Anyone who can assume this role can theoretically call inference for any model. How do you protect how do you protect against that? You wanted to ensure that this policy is used only from one particular place, for example, Lambda in our example. So for that, you use trust policy. Notebook in this particular case, or Lambda in a serverless application, can assume this particular role only because it's explicitly allowed to do so in the trust policy. We'll just open it up in a second. If you try to assume the access role in another component, it will be implicitly denied. So let me show you the trust policy here. That's the role we assume. And here under the trust relationship tab, there's a trust policy which explicitly allows the role under which the SageMaker notebook is running to assume this particular role. And it also explicitly allows SageMaker notebook role to tag temporary session with tenant ID tag. So you basically have to have these two statements to be able to do what I just demonstrated, to assume role and tag the temporary sessions.
So in this solution, we're using ABAC to implement the tenant isolation. In previous show on the series, we've talked about dynamically generating policies. Would it be possible to use the same or get the same results using dynamically generated policies?
Yes. You're referring to the Twitch episode just a few weeks ago by Bill Tarr. Yeah, a very good one. I definitely recommend everyone to take a look. So both approaches have many similarities. And in both, you create a temporary session with tenant-specific security context by calling Assume Role API. However, the difference is that in ABUC, you use a parameterized policy which is already stored in IAM. And in dynamically generated policies, you create a policy in your own code. All right, so let me show you one last thing. So you probably noticed that I have in here another notebook which demonstrates a bit different approach. Here we use 2 single model endpoints, each with a dedicated model, right? So in the previous example, we used one multi-model endpoint with multiple models. Here we use a dedicated endpoint with one model. You can use ABUC to restrict access to endpoints, as well as we did for model artifacts with multi-model endpoints. And there is a very small difference here. So first of all, in invoke endpoint, we don't have to pass model artifact name anymore, right? Because it's just a single endpoint, single model endpoint. And the next big difference is in the policy that we assume in here. Let me open it up. So in the previous policy, we had a condition that checked artifact name to start with tenant identifier. In here, we have just a resource that has to include tenant name in its name. And if we, so you see, we just construct the ARN dynamically in this policy without using any conditions. And when we pass the endpoint name, it has to be for the same tenant for which we create a temporary session. So these two steps have to happen together for this policy to work. So let me execute this. All right, and if I'll change here the tenant 1 to tenant 2 and execute it again, it will be denied by IAM. So that concludes the demo. Altogether, we covered 2 parts, started with training and concluded with inference architecture. We discussed how to deal with multiple tenants, different requirements specific to software as a service applications, looked at silo versus pool, and also explored how to use ABUC with IAM to isolate tenant on the infrastructure level.
Very interesting stuff, Michael. Just a question on the last part. When would you use the bridge model as a solution?
That's a good question. I actually should have mentioned that. So this is actually the bridge model. So if we just open the slides, let me open the slide. So the bridge model is similar to the pool model with respect to the reused API gateway and Lambda. But for the inference endpoints themselves, they use silo approach. So as we see here, we use dedicated inference endpoints on one hand, and shared Lambda and API gateway on the other hand. Altogether, we have an architecture which is combined from some components in pooled mode and some other in silo mode. So that sort of architecture is called bridge. And as I demonstrated, you can make use of ABAC for that sort of architectures as well.
But so it's mainly just your own preference, maybe, when to choose one over the other? Or do you see any specific use cases where one would be preferred?
So this particular approach is very practical ones because on the one hand, you reuse API gateway and Lambda, smaller number of components, easier to manage, smaller risk of hitting the limits. On the other hand, by using dedicated inference endpoints, you can ensure consistent inference time and reduce noisy neighbor impact on the inference part. So that's a very practical approach where you combine or balance cost with consistency of inference. And it's definitely, I'm very glad that we managed to cover this piece as well, because it's so practical.
Yeah, very good. Meran, I want to put you on the spot before we wrap up as well. Did your pipelines finish? You're muted, Meran.
Yeah, let me share my screen. Okay, so you can see that these two pipelines are finished. All the steps gone through, and might be the last point I want to show you is that Cost Explorer. If you remember, I passed like tenant A or tenant B as a payer, and you can see here easily that the tenant A was charged like 4 cents for that pipeline execution, and tenant B was 7 cents. So because they use different set of CPUs, different number of instances, and that would help you to understand that how much is the actual cost per tenant, and then you can do some finance to calculate the number of dollars you want to charge your customer per their tenant subscription level.
That's great. All right. So with that, it's time to wrap up. Meran, Michael, thank you very much for joining me today on Building SaaS on AWS. Thanks to all the viewers who were with us in this through this hour. We at Building SaaS on AWS is, of course, back in 2 weeks again. So do join us then. So thank you all very much.
Thank you.
Thank you.